Let's continue looking at more types of figures that we can create with Matplotlib. And let's move to describing distributions using histograms and pie charts. So let's begin with the histogram, which is quite simple. So to create a histogram, we just call the hist function. And we give some x values and the number of bins that we want. And that's basically it. So Matplotlib will simply take the data points, will split it into those bins, count how many occur within each bin, and then give you this nice plot that you see here. So you can see the distribution of the net surface charge of all the different viruses. And that's by default, so you can play with that. You can give some custom bins if you want. You can ask it to normalize the y-axis and all kind of stuff. But that's like the basic use case. And as pie charts go, again, quite simple. So let's see an example. So we want to show how many viruses occur within each one of the 5 groups that we have defined. So we first count how many records are per group. So we create a list with the 5 items, each one corresponding to the one of the 5 unique groups that we defined earlier. And we just count how many there are. And then again, we use the same trick to define 5 different colors to show each one of the 5 groups. And then we just use the pie function, and we give the number of records per group. And that's the numbers it's going to use to produce this pie chart. And we provide the labels, which are simply the unique groups which we define, and the colors. And we can also provide some format in which we want to present it. So I think by default it shows it without a percentages or something. So here I want it to be just one digit and then to show the percentage. So I provided different formats. And that's basically it. Let's see how we work with box plots. So here we want to compare the distribution between the inner and the outer radius of viruses, and we want to see which is bigger. And clearly the outer radius is bigger. Now the way we produce it, we simply call the box plot function, and we can give it a list of collections. So each collection can be a NumPy, it can be a series, it can be a list, a set, whatever you want. So each one of those is just a collection of items. It doesn't have to be necessarily of the same size. Here we just use different columns, but it could be basically anything. So the first one would be the values from which it will extract the distribution of the first box, and then the values for the second box, and so on and so forth. So we can create as many boxes as you'd like. And then we can use the setXtics labels to give the labels we want to each one of those groups. So we want to name the first inner radius and the second outer radius, and that's what we do here. And as usual, we can set a y label and set a limit, and we want to set specific ticks, and we also want a grid. So all of those values we can set here and get the exact customization that we want to show. And by default, it will, again, show you the boxes, which are the Q1 and Q3, and the median. And the whiskers, by default, is exactly what we said. It's 1.5 times the IQR. And you can see that everything outside of the whiskers is shown as an outlier, like you see here. OK, so we have quite many outliers. Sorry. And yeah, so it's quite simple to use the box function and to just give it values, and it will make all the statistical calculations and draw the appropriate box plots. If you want, you can also do those calculations yourself and just give it very explicit drawing instructions. So you can do it yourself and like ask Matplotlib to tell it that you want the mean to be 4.2, and you want the median to be 5.9, the Q1 and Q3, and the lower part of the whisker and the higher part, and also the outliers using the flyers. So just providing a dictionary with the exact value, and then you use, instead of the box plot, you use the bxp function, and you give this list of dictionaries, and each one has its own drawing instructions, and it will just draw exactly what you ask for. So you will decide exactly where you want the median to be, where you want the mean, where you want the whiskers, if you want outliers, everything. By default, the box plots don't show the means. So if you want the means, you need to use show means equals true. And as always, I'm not showing you all the different options and different things you can tweak. If you want to see the full options, you can just go to the documentation and see everything that you can change. So each one of those functions that I'm showing you has like dozens of different parameters that you can tweak and change. OK, now let's see an example of a heat map. So in this example, we actually illustrate the Blossom 62 substitution matrix. So we take all the 20 to 20 amino acid matrix, and we want for each pair to see what's the value of Blossom 62. And we use this nice scale, which goes for negative values will be blue, positive values will be red, and 0 will be white. And then you can actually see like which substitutions are more likely. You can definitely see that the diagonal, as expected, is very strong, and all the rest. So let's see how we can create this heat map as an example. So we first begin with importing the Blossom 62 matrix from Python, and we create a string with all the 20 amino acids. And we create a function that, given 2 amino acids, will give us the Blossom 62 value. And the reason that we need this function is that Blossom 62, if you remember, is just a dictionary. But it's partial dictionary. So for each pair of amino acids, you will have them just once, and you don't know which will go first. So every time that we want to check a specific amino acid pair, we need to check whether the first and the second, or the second and the first, we try each of those. So at least one of them will give us a value. It will be in the dictionary, and we get the Blossom 62 value. And then we create an NumPy matrix with all the different values. So we use this list comprehension within another list comprehension and convert everything to a NumPy array using this function that we defined to basically get just all the Blossom 62 values. So you can see that the data is nothing more than a 20 by 20 NumPy matrix with all the Blossom 62 values according to the ordering that we define here. And then to create a heat map, we just use the pcolor function, which creates a heat map. And we give the 2-dimensional NumPy matrix as the data. And we specify the color map that we want. So here we want the BWR, which stands for blue, white, red. There is actually a closed list of all the possible color maps that you can use. I'm going to show you it in a moment. But for now, just know that BWR is just some color map that we can use. And we actually explicitly specified the minimum and the maximum value that we want this color map to use. If we don't specify explicit values, it will use just the minimum and maximum that we have. But the reason that here it was important to actually specify concrete values and moreover to make sure that they are symmetric is because we want the middle one to be exactly 0. So we want the white to correspond with the white color to correspond with a 0 value. And we do that by specifying symmetric positive and negative values. And now we can see that whatever is white is exactly 0. So that's a way to preserve this symmetry. And also it's important not only to show the heat map itself, but also to show this color bar to the right, so that the person looking at the color bar knows what a color means. And for that, we use the color bar function. OK, notice that it's a function not of the axis like most of the functions we've seen. It's a function of the figure object. And we just give it the heat map that we created, and it knows how to create this color bar that you see here. And finally, we want to set the x and y axis ticks, so we can see which amino acid is any one of those rows and columns. So we set the x ticks to be to be all the range, and we need an offset of 0.5 because we want it to be in the middle of each square. We don't want it to be just at the beginning. And then the tick labels, we just give these 20 amino acids. And finally, we give it a title, and that's it. Questions? OK, so I mentioned that you can use color maps. I put a link here if you want to see in the documentation of Matplotlib. You can see all the different color maps that you can use. So you can actually choose which one you find the most appealing. So we used this one, the BWR, which you see it's a diverging color map, starting with blue, going through white to red. And I actually prefer those diverging color maps because, again, they're quite simple. So for heat maps, it makes a lot of sense to use them. So it's very easy to understand which is high and which is low. But you can also have all of those crazy color maps if you want. Anything goes. And you can even define your own color map. You can specify a function which actually gives the RGB values and do anything you want, really. OK. So I said quite many times during this talk today that I think Matplotlib's interface it could be better, let's say it this way. And I want to show you some concrete examples in which it can be sometimes misleading. So I mentioned to you that for most of the things you want to do, you just want to work with the axis objects, like if you want to set plot or set xticks and all the rest. But for some reason, they also gave you these shortcuts that you can work with. You can work with the module directly and, for example, use plot.plot, not just the axis objects. And you can also set the ticks using this interface. Now, the annoying thing about it is that it's not even consistent. So you notice that for the axis objects, you have the set xticks function. But for the shortcut, it's just xticks. And that's actually quite common. So you can see many kinds of inconsistencies like that. So pay attention to that. For example, if you search for help and you see some people writing about it in Stack Overflow, many times you will see they refer to one of these options. And you will try it in a different context, and it won't work for you, and you won't understand why. So be careful to this distinction. And like I said, I really recommend you just not to work with the shortcuts. Just work directly with the axis objects. It's more explicit, and you have all the functionality that you need. So it's better to work this way. Another way in which the interface is sometimes a bit confusing, for some reason they decided to create this thing they call the PyLab, which is a submodule, which is actually nothing more than just a shared namespace for both pyplot and numpy. So again, many times if you search for help and you see example online, you'll see people using the PyLab. And from the PyLab, they use both numpy functions, like you see here, the arange and the sinus function, which are clearly functions related to numpy. And then they also use the plotting functions, which are related to Matplotlib. This just creates a mess, and it couples things together which shouldn't be coupled. So you have numpy and you have Matplotlib, which should remain distinct. So again, very unrecommended to use this PyLab shortcut. Just use numpy and Matplotlib, each one whenever it's more appropriate. Now, Pandas has some nice shortcuts, which I actually do recommend you to use sometimes if you want to do just simple stuff. So it can spare you a little bit of code writing. So for example, if you want to take this data frame of ViperDB and we want to plot to make a scatter plot of 2 columns, you have a shortcut for that. Instead of extracting those columns and calling the Matplotlib functions, you can just use the plot function of the data frame. You can specify what kind of plot you want. So in this case, we want a scatter plot. And you just specify which columns you want the x and the y axis to be. And it already creates you this nice figure. And it even gives you appropriate labels. So you don't need to manually set them. So we can actually use it in just one line of code with Pandas. We can even create even more kind of complex graphs like the one we saw before. So let's see an example. So we can first filter just the data frame that we want. And then on that filter data frame, we use the plot function. And we can give it a different axis because here we want a larger figure size. So we first create the figure and the axis, and then we provide it as the kind of axis that we want it to be plotted into. Again, we want it to be a scatter plot. We want these x and y columns to be the x and y axis. We can provide a title that we want to add, and we can set the S and C attributes to specify what sizes and colors we want.
Is it a problem with setting AX equals AX?
This one?
Yeah.
Why would that be a problem?
Some sort of confusion between different variables?
No, so you can, there is no problem with a function argument name having the same name as some global variable that you use. So whenever Python sees this syntax, it knows that what you mean is you want the x argument to be equal to the x variable. So it knows that the first one is a function argument and the second one is a variable. So there is no collision here. And then within the context of the plot function, every time there is a reference to x, it clearly refers to the argument because it's not a global statement there. And yeah, and you can see here the same kind of more complex graph that we created earlier. Of course, it does depend on all of these pre-processing work that we did earlier. So defining the colors that we worked hard before that to create. But once we have that, we can just use Pandas shortcut to spur some lines of code and make it just in one line, basically. And let's see, find an example here. We use, we create a series and then we plot it as a pie chart. So first, how we create this series, we just use the records per group that we defined earlier, and we give it an index and a name. And you can see that we get this nice series that maps each group name to the number of records. And then again, we define the colors that we want. And then we, on top of this series, we use the plot function. We say we want it as a pie chart. We specify which axis we want, which colors, and the label formatting, and we get it. So if you're interested, I gave you here a link to a more elaborate documentation of everything you can do, all the Pandas shortcuts for visualization that you can make.
So basically, anything I can do with Matplotlib library, I can do with Pandas.
No, I wouldn't go as far as to say that you can do everything with the shortcuts. I think it's more limited. So many times you will be forced, if you want default stuff, just the basics, then yeah, the shortcuts can spare you quite a lot of efforts. But if you want more complex kind of plotting, then you will probably have to use Matplotlib directly. Yeah. Okay, and as a final topic I wanted to cover, I want to talk a little bit about styles. So for this discussion, I created this function, which just creates a figure with 3 axes, each of them with a different kind of plot. And by calling this function, I get this figure and the axis, and you can see that we get those kind of figures that you know. Now, like I said at the beginning, I think the default design of Matplotlib is decent, but it's not like the most beautiful design you can ever see. Now, there is a way to change that. We can use within the style submodule, you can change it using the use function. And there are a number of predefined styles which we can use. For example, there is this very common style which is called the ggplot, which tries to emulate the aesthetics of the ggplot within the R environment. For those of you that use R, this looks a little bit more like the kind of plots that you see with R, and you see it has a somewhat different style and looks to it. Sometimes if you use it out of the box, it will look slightly better, and some people prefer this style. So you can see I used the exact same function, but once I run this statement, it changes the entire default style of everything I do with Matplotlib. If we want to recover the default style, it turns out to be a very non-trivial task, and it took me a long time to find exactly how to do that. And yeah, so another example for why the API of Matplotlib can be annoying. So don't ask me why you need to do that, but that's what you need to do. So you need to run this function and then run this magic command, and only then will Matplotlib be willing to restore the default style. Yeah, but then you can use other styles. So for example, there is the BMH, another nice looking style. There is 538, which is a popular website, and this style tries to imitate that. And there are many different styles. So if you choose plot style available, you will get a list of all the available styles, and you can try them one after the other and see what they look like.